We have made the decision to choose the topic of linear programming. To start with, we have made an introduction. It all began with the simplest method developed by Dorothy in 1947. Linear programming is a mathematical optimization technique that's used whenever we want to optimize, minimize, or maximize any specific objective function. For example, it can be cost, consumer utility, or benefits or production of a company. It has been used in the oil industry, military as well, and also in the service sector and in the public sector of economy. Related to economics and business, it can be applied to transport problems, resources allocation, and production. To create a problem, we need two basic and essential elements. One of them is the objective function. This is the function we're going to work with in order to get the solution, and it's the one we're going to maximize or minimize in the problem. The second basic element is the set of constraints. Those are equations or inequalities, conditions that the variables of the problem must satisfy in order to get the right answer. We can also find two more structures, however, they're not essential to get the solution. Those are non-negativity constraints and graphical solutions.
Now we're going to work on the case of Avalon. Avalon is an enterprise that was founded in 1911 as a family business, dedicated to the manufacture, treatment, and handling of paper and paperboard products. Although it produces many products, his objective now is to maximize the weekly production of three products: fish boxes, border partitions, and kitchen paper roll tubes. To produce them, they use several components, each of it with a specific function specified in the PowerPoint, and in different quantities depending on the product. The first two are corresponding to raw materials, and the next five are chemicals. In this box are shown the quantities of the components for each product. The price for each product is €1.69 for the fish box, 16 cents for the border partitions, and 6 cents for the kitchen paper roll tubes. So the resulting objective function would be that with X meaning the number of fish boxes sold per week, Y meaning the number of border partitions sold per week, and Z meaning the number of kitchen paper roll tubes sold per week. In the next table is shown the storage limitation the company has. With all those, we construct our 7 constraints, because each product has a storage limitation. Of course, we understand that X, Y, and Z have to be greater than 0, so that we have to add those non-negativity constraints. So with all this, we now have our problem set up, and we're going to use Excel to solve it. We put on Excel the data, the variables, the constraints, the function, and we obtain a result where the constraints are respected. So it is feasible.
We're now going to analyze the results of the problem. If the company wants to achieve the goal to maximize their weekly profit, they should sell 1,978 units of fish box, 6,880 units of butter rolls, and 2,977 units of kitchen rolls. By these measures, the company will obtain a weekly profit of €4,622.24. To maximize the production, the grams of flocculant, starch, and imbo must be almost totally used. Now we will indicate some of the products that are not totally run out, like water, waste paper, glue, and deformer. Finally, it must be said that 11,635 units of finished products must be produced in the company to maximize the weekly profit of this combination of materials. So, to the data shown on the previous slide, we get to the conclusion that the company should reduce the purchase of those materials that are left over in order to reduce cost in production.